Dear student, today we are discussing the class 9th level chapter and the chapter name is Property of Parallelograms. Property of Parallelogram. In this chapter, we are discussing two important theorems which is most important for the board exam as well as the competitive exam. At first, we are discussing the first theorem, then we are discussing the second theorem. Now we are discussing the first theorem of this chapter. The theorem: in a parallelogram, a diagonal divide the parallelogram in two equivalent triangles, and the part says that opposite sides are equal and the opposite angles are equal. So in this theorem we are discussing the 3 points of 1, 2, 3. Now given that, according to this picture, given that ABCD is a parallelogram and AB is parallel to DC and AD is parallel to BC according the property of a parallelograms. So this is the parallelograms and this is the parallel sides of the given parallelograms. Now AC is a diagonals. AC is a diagonal of ABCD, parallelogram ABCD. Now this diagonal give us two triangles, the triangles ABC and the triangles ADC. Prove that first part, the triangle ABC is the equivalent triangle of ADC, and the second part, AB is equal to DC, AD is equal to BC, and the third part opposite angle. So the angle ABC is equal to the angle ADC and the angle BAD is equal to BCD. So we move to the next part, construction. No construction is there. Now we move to the proof section. For the triangle ABC and the triangle ADC. For these two triangles, the angle, these angles and that angles are equal. Why equal? BAC is equal to the angle ACD because of this figure, DC and AB. So these angles and that angles are equal because these two sides are parallel to each other and this is the sector, this AC is the sector. So these two angles are the same. Similarly, we can say the angle, this one and that ones are equal. So the angle ACB is equal to the CAD. So ACB is equal to CAD. Similarly, we can say that this one and that ones. This is the DA and this is the CB. Since AD and BC parallel to each other and AC is a sector, so these two angle is also equals, and now AC is equal to AC. This is a common side. So by the property of angle side angle, we can say these two triangles, the triangle ABC is equivalent to the triangle ADC by the property of angle side angle. So this is the proof of first part, and now by the property we can prove this, that is AB is equal to this, the AB is equal to DC and AD, this is the AD, and AD is equal to BC by the property of CPCTC, common property, common triangle congruence. So second proof is complete. Now we move to the third proof. So these angles and that angles, that is the ABC and ADC, already proved because of ABC is equal to ADC, same CPCTC. This is the proof by the common property of common triangle congruence. Now the next, this part we are discussing that if we adding these two angles, these angles and these two angles, then if we adding this angle and that angles, because of this angle and that angles are equal, similarly this angle and that angles are equals, if we are adding these two angles by using these two, then you get BAD. There is a BAD, and when you adding these two sides, there's the, and then we get BCD, which is also required result of this one. So this is also proved by adding up 1 and 2. If we put this is the 1 and this is the 2, so adding up 1 and 2 we get this. That is the three part we are discussing. These two triangles are equivalent by the property of angle side angles, and these two side AB is equal to DC and AD is equal to BC is equal to by the property of common property, common triangle congruence. And similarly these two angle ABC and ADC, ABC and ADC is equal to by the property of common property, common triangle congruence. And similarly this part, if we adding this BAC, this is a BAC and CAD, BAC and CAD, these two, and when we adding ACD and ACB, then we get this. This is a complete of first theorems, and now we move to the second theorems of this chapter. Dear student, if any questions arise in your mind about these theorems, you can put your question in comment section. Now we move to the second theorem of the day. The second theorem says that in a parallelogram, the two diagonals bisect each other. That is, this is A, B, C, D, and AC and BD is a two diagonals, and they intercept each other at the point of O. Now, given that ABCD is a parallelogram and AC and BD are two diagonals, and O is the intercept point. Now we want to prove that AO is equal to OC as well as BO is equal to OD. Construction no. So there are no construction in this theorems. Now in proof section, now if we discuss two triangle AOD and the triangle BOC, then we can say OAD is equal to OCB. Why? Because this is the DA and this is the C and O point is there, and this is the C and B, and this angle and that angles we are discussing. Why these two angles are equal? Because AD and BC are parallel to each other. Why these are parallel? Because ABCD is a parallelogram, so their opposite side must be parallel to each other, and these two sides is the AD and BC is the opposite side, so these two angles must be equals. And now move to the next part, that is that AOB is equal to COD. These are opposite angles, and we know that opposite angle is always equal. So this is the AOB and this is the D and C. So these angles and that angles are equal. Now AD is equal to BC. These two sides is also equal. Why? Because these two sides is the opposite side of the given parallelogram ABCD. So by the property of ASA, we can say that these two triangles are equivalent triangles. Now by the equivalent triangle property, we can say by the property of CPCTC, which is our equivalence. So this is a complete of the second theorem's proof. Hope the given information and the discussions of these two theorems, the constructions and proof and the discussions about these two theorems increase your knowledge and enrich your knowledge about these two theorems, and when we practicing these two theorems in future, then this video extend your knowledge about this